All right, so what I'd like for you to do in this lesson, I'd like for you to start by pausing this video and draw the Lewis structure for sulfate based on the information that we have been provided up to this point. So when you drew sulfate, you should have found that it looks something like this. Okay, so here's sulfate, where oxygen has our lone pairs, which I've just drawn a line for instead of the dots. That's fine. And it is a 2 minus. All right. So the goal is for each bond to share energy equally. So each bond really wants equal energy. Now, we can determine whether it has equal energy or not based upon what we call a formal charge. Now, there's a couple of different ways to do formal charge. And this is the way I do it. I take the number of valence electrons and I subtract out the assigned electrons. And my assigned electrons can come from lone pairs. Lone pairs will equal 2 electrons each. Or they can come from bonding pairs. And bonding pairs will equal half the electrons in a bond because bonds are sharing electrons. So let's look at the formal charge of sulfate based upon the way we have been drawing it up to this point. Sulfur has 6 valence electrons. So number of valence electrons, 6, minus assigned electrons. Sulfur has 1, 2, 3, 4 bonding pairs. Each one has 2 electrons. Because these electrons are being shared, we take half. So 1, 2, 3, 4 total electrons. So sulfur has a formal charge of +2. Now, each one of these oxygens is going to have the same formal charge because they both have a single bond with the sulfur and 3 lone pairs. So oxygen also has 6 valence electrons. It has 2 electrons from this bonding pair, plus another 2 electrons, plus another 2 electrons, so 6 total electrons, plus this, I'm sorry, I just said bonding pairs, I meant lone pairs. It has 2 electrons from this lone pair, 2 electrons from this lone pair, and another 2. So 2, 4, 6 electrons from the lone pairs. These are not being shared with anything, so they all go to the oxygen. Now, oxygen is sharing 2 electrons with sulfur. So since it's sharing, we're going to divide that in half. Half of 2 is 1. So we have 2, 4, 6 plus 1 is 7 total electrons. So oxygen has a formal charge here of minus 1. Of minus 1. Now, our goal is to try and get to as close to 0 as possible. So the closer the formal charge is to 0, the more energetically favorable. All right, so the closer the formal charge is to 0, the more energetically favorable those bonds within that molecule are. And so the reality is, if we look at the formal charge of sulfate the way we've been drawing it, neither one is at 0. And so what if I told you we could redraw sulfate to get a more energetically favorable compound? And in order to do so, if we put a double bond between the two of the oxygens and a single bond between two of the oxygens. And again, we need to put in our lone pairs. Now, let's check out the formal charge. What is the formal charge of sulfur? Sulfur, again, has 6 valence electrons. So we're going to do valence electrons minus assigned electrons. What are my assigned? It has 2, 4, 6, 8, 10, 12 shared electrons. So half of 12 is 6. So sulfur now has a formal charge of 0. Let's look at our oxygen with the double bonds. And I'm just going to put a double bond in front of the oxygen to distinguish. Oxygen has 6 valence electrons minus my assigned electrons. So looking at my oxygen with the double bond, it has 2 lone pairs, so 2 plus 2 is 4, plus 2 from these shared electrons, so it's sharing 4 electrons, half of that is 2. So I have 2 plus 2 is 4, plus 1 is 5, plus 1 is 6. So my double bonded oxygen has a formal charge of 0. What? All right, let's look at our single bonded oxygen. So my single bonded oxygen still has 6 valence electrons. It has 2, 4, 6 from the lone pairs, plus 1 being shared is 7. So this is more energetically favorable because I have more parts of the overall compound closer to 0 than I did in the original way that we drew it. So the reality is, when we introduced this unit to you and we drew sulfate, we lied to you. I'm sorry, friends. We lied. All right. The more energetically favorable way, and the way sulfate actually is going to appear in nature, is with 2 double bonds and 2 single bonds. Formal charge, okay, should always add up to the charge of the ion or the molecule. All right, so sulfate has a charge of 2 minus. So let's look and let's add up our formal charge. I have 1 sulfur, which has a 0 formal charge, plus I have 2 double bonded oxygens, which are both also at 0. All right. So I have both of my double bonded oxygens at 0. I have 2 oxygens at a single bond, and these both have a formal charge of plus 1, so plus 1 for each of those oxygens. So overall, and these are a minus 1. Y'all, I'm so sorry. It is Friday. It is Friday, and I have made about 15 videos today. All right, these are negative 1s. Please forgive me. 6 minus 7 is negative 1. All right, so I have negative 1 and a negative 1. So let me start over because I might have confused some of y'all. I have my sulfur. I have my 2 double bonded oxygens, which are both 0, minus 1 for this oxygen, minus 1 for this oxygen. So overall, I have a minus 2, which does match the charge of my sulfate. So go ahead, draw and assign the formal charge of nitrate. So pause this video. All right, so when you drew your nitrate, you got something that looks like this. Now again, I drew my lone pairs with dots, but it is okay to draw lone pairs as just a straight line as well. All right, because a straight line in a bond represents 2 electrons. So when we draw these straight lines, we're still representing 2 electrons. So either way is fine. All right, and let's look at our formal charge. Let's look at nitrogen. Nitrogen has 5 valence electrons, minus 1, 2, 3, 4 electrons. So it has an overall +1. Now nitrogen has resonance, so you may have put the double bond at the bottom or on the other side. That's perfectly fine. Let's look at our double bonded oxygen. It has 6 valence electrons, 2, 4 from the lone pairs, +1 is 5, +1 is 6. So the double bonded oxygen has a formal charge of 0. Let's look at our single bonded oxygens. Oxygen has 6 valence electrons, 2, 4, 6 lone pairs, +1 is 7, so it has an overall -1. So if it is in fact true that the formal charge should add up to -1, let's do it. I have 1 nitrogen at +1. I have 1 double bonded oxygen at 0. And I have 2 oxygens both at a -1. So +1 plus 0 is +1, -1 is 0, -1 gives me an overall -1, which does match the charge of nitrate. So now what I'd like for you to do is I'd like for you to draw chlorate based upon our original rules for Lewis structures, assign formal charge, and then determine if there's a more energetically favorable way and prove that by the use of formal charge. So go ahead and pause this video and get that question answered. Okay, so based upon how we have been drawing chlorate up to this point, you would have drawn it to look something like this, where we are able to make it with all single bonds. Because we learned the rule, we said that compounds don't make double bonds if they can make it work with a single bond, which isn't really true. All right, that is kind of a lie. Let's go ahead and assign our formal charge here. All right, so chlorine has 7 valence electrons, minus 2 from the bonding pair, 3, 4, 5. So chlorine has a formal charge of +2. Each one of these 3 oxygens is going to have the same formal charge. 6 valence electrons, 2, 4, 6 from the lone pairs, +1 is 7. So that is a -1. So overall here, when we draw this, we want to try and get closer to 0. All right, So let's get closer to 0. So the way we can actually get it closer to 0 is by making a double bond and giving chlorine, or not chlorine, chlorate, giving it some sort of resonance. All right, so in my first molecule, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So here I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So by doing this, I've gotten my formal charges closer to 0, and I am a more energetically favorable molecule. Let's look at chlorine. Chlorine has 7 valence electrons. It has 2 from the lone pair, 3, 4, 5, 6. So chlorine is a +1. Let's look at my double bonded oxygen. Oxygen has 6 valence electrons, 2, 4, 5, 6. So my double bonded has a 0 formal charge. And my single bonds, 6 valence electrons, 2, 4, 6 plus 1 is 7, equals a -1. So this is in fact more energetically favorable because I've gotten rid of the 2 altogether. I have a 0 here for one of the oxygens. So let's just double check and make sure that our formal charge does add up to -1. So I have 1 chlorine at a +1. I have 1 double bonded oxygen at a 0. I have 2 oxygens at a -1. So when I add these all together, +1 and a -1 plus 0, this is all 0, plus a minus gives me a -1.